Also note that the following, the integration of x power r d of x will be x r plus 1 over r plus 1. So we add 1 to the power and then we divide by the new power r plus 1 plus the constant c, where r is not equal to minus 1. What is the case, or what is the integration if r is equal minus 1? For the case we have integration of 1 over x d of x. So if r, or if the power is minus 1, the integration will be ln absolute value of x plus the constant c, where x here is not equal to 0. So now let us see this example, which is example 2. Evaluate the following. Integral of 1 over root of x d of x. So first we need to rewrite this one as a power function. So 1 over root of x will be x power minus half. And we know that if you have a power rule, so we use this one. The integral will be x power r plus 1 divided by r plus 1 plus the constant c. Here our r is minus half, which is not equal minus 1. So we can add 1 to the power, then divide by the new power. So it will be x power minus half plus 1 divided by minus half plus 1, then we add the constant c. So now minus half plus 1 will give us half, so it will be x power half. And here we have minus half plus 1 will be half, so 1 over half, this will give us 2. Here we have root of x plus the constant c. Then b, we have integral of sine x over cosine square x d of x. So this one, sine over cosine square. We can rewrite cosine square like cosine multiplied by cosine. So we'll take sine over cosine multiplied by 1 over cosine. And we know that sine over cosine is just tan, and 1 over cosine is sec. So now we need to find what is the integral of tan x sec x d of x. What is the function? That's when you integrate, once you differentiate, you will get the result tan x sec x. So this will be sec x plus the constant c. Because if you differentiate sec of x, it will be sec tan x. So this is the antiderivative of tan x sec x is sec x plus the constant c. If you need to know if you are going right or your answer is your step is correct, just try to differentiate the result, the final result. So now the derivative of sec will be sec tan, and we have whole sec tan. Derivative of 2 root x, it will be 2 multiplied by x power half minus 1 divided by half minus 1, where half minus 1 will be just minus half, and here we divide by this one. So here we have also theorem 5.1.2, which is properties of the indefinite integral. Let f prime x is equal f of x and g prime x is equal g of x. Then the integral of the constant multiplied by f of x d of x will be just constant multiplied by the integration of f of x d of x. And we know that we said the integral of f of x is just the function f of x plus the constant c, where k is any constant. Similarly, like the differentiation, if you want to differentiate summation or subtraction between two functions, you can differentiate the first one, then plus or minus the differentiation of the second one. Similarly here, the integral of fx plus or minus g of x will be integral of fx plus or minus the integral of g of x. So here you can distribute the integral sign between these two functions. Then you need to add the constant c. Once you distribute the integration, you don't need to add here, for example, the integration of fx will be f of x plus c, integration of g of x will be g of x plus c, then you have to c no, because c is any constant, so one c will be enough. يعني لما أكون عندي عملية جمع أو عملية طرح وأنا أجيب الانتجريشن لتو function، يعني betweenهم summation أو subtraction، ما يحتاج أضيف c حال كل function. آخر شيء لما أجيب الناتج مال الانتجريشن أضيف c اللي هي c واحدة تمثل الانتجريشن مال الفانكشن fx ومال الفانكشن g of x، لأنها c عبارة عن constant فتكون أي عدد. فأنا لو أضفت مثلا لانتجريشن مال fx c1، الانتجريشن مال g of x c2، في الأخير بيصير هنا عندي fx plus or minus g of x plus c1 plus c2. c1 و c2 بثنتينهم أصلا مجهولات، يعني it could be any number, any constant number. فالأفضل أنا أكتب c واحدة اللي هي تمثل نفسها c1 plus c2. So here we have example 3, integral of 2x power pi minus 3 over x plus sec square x d of x. So for this one we can distribute the integration because here we have minus, here we have plus. So it will be integral of 2x power pi d of x minus integral of 3 over x d of x plus integral of sec square x d of x. Now we will find the integration of each one of these functions. 2 is a constant, so it will be 2. Integral of x power pi, we will add 1 to the power divided by the new power. So it will be x power pi plus 1 divided by pi plus 1 minus. Here we have 3 over x, so 3 is a constant. Integral of 1 over x, we said it is ln absolute value of x plus. The integral of sec square will be tan of x, because if you differentiate tan, you will get sec square. Then we add finally the constant c for all these functions. Then we have example number 4, evaluate integral of x plus 1 all square over root x d of x. So for this one, it is unlike the differentiation. Once we differentiate, we use the quotient rule. But here in the integration, no. First, you have to find what is x plus 1 all square, which is x square plus 2x plus 1, divided by root of x. Then we will take x square over root x plus 2x over root x plus 1 over root x. Then we can find the integration of each of these separately. So now we have x square over root x, it will be 2 minus half, so it will be 3 over 2 plus 2. Here we have x power 1 over root of x, so 1 minus half, this will give us half, so 2x power half plus, here we have 1 over root of x, which is x power minus half. So now to integrate this function, just integrate each one separately. The integral of x power 3 over 2, so we'll add 1 to the power, so it will be 3 over 2 plus 1, which is 5 over 2. We divide by the new power, which is 5 over 2, plus 2 is a constant. Integral of x power half, so we'll add 1 over 2 plus 1 will give us 3 over 2. So here we have x power 3 over 2, we divide by the new power, which is 3 over 2, plus. Here we have x power minus half, so the integral will be minus half plus 1, which is half. So x power half divided by half, then we add the constant c. If you want to simplify this one, so we'll get 2 over 5 x power 5 over 2 plus 4 over 3 x power 3 over 2 plus 2 x power half plus the constant c. Now let us see part B. We have integral of x power 6 over 1 plus x squared d of x. So for this one, you cannot say it is x power 6 over 1 plus x power 6 over x squared. No, this one is different. Here you can take x squared over root x plus 2x over root of x plus 1 over root x. But for this one, no, you cannot say x power 6 over 1 plus x power 6 over 2. No, this will be wrong. So for this one, if you have here, this one is higher power than this one, you will do the long division. So here we have x power 6 over 1 plus x squared. So we will divide x power 6 over x squared plus 1 by the long division. So here we have x power 6 over x squared will be x power 4. X power 4 multiplied by x squared plus 1 will be x power 6 plus x power 4. We subtract, so x power 6 minus x power 6 is 0. Here we have minus x power 4. So now minus x power 4 divided by x squared, this will give us minus x squared. Minus x squared multiplied by x squared will be minus x power 4. Minus x squared multiplied by 1 will give us minus x squared. Now again we subtract. Minus x power 4 minus x power 4 will be 0. Here we have minus with minus x squared, so it will be x squared. X squared divided by x squared plus 1 will give us 1. 1 multiplied by x squared plus 1 will give us x squared plus 1. So x squared minus x squared will be 0. Here we have minus 1 will give us minus 1. So now here you cannot divide minus 1 by x squared plus 1, because here the power 0, here the power 2. So we conclude that x power 6 over 1 plus x squared will be x power 4 minus x squared plus 1, and the remainder will be minus 1 over x squared plus 1. Do not write the remainder minus 1 only. No, it is minus 1 divided by x squared plus 1. So we say that x power 6 over 1 plus x squared will give us this one. So now we need to find the integration of this function. So the integration of x power 6 over 1 plus x squared d of x will give us the integration of this function. So now the integration of x power 4 will be x power 5 over 5 minus integration of x squared will be x power 3 over 3 plus integration of 1 will be x minus integration of 1 over x squared plus 1. If you integrate this one, if you remember that the derivative of tan inverse will be 1 over x squared plus 1. So that's why the integration of 1 over x squared plus 1 will be tan inverse x. Then finally we add the constant c. Then we have question number 20. So t cube minus 8t plus 1 over 2t all power 4 dt. For this one we can take t cube over 2t all power 4 minus 8t over 2 power 4 t power 4 plus 1 over t power 4 t power 2 power 4 t power 4. So now if you simplify, so 2 power 4 will be 16, so here we have 1 over 16. T power 3 over t power 4 will give us 1 over t, d of t, minus integral of 8 over 2 power 4 will give us 8 over 16. T over t power 4 will give us t power minus 3. Then plus, for this one here we miss the integral sign, sorry, so here should be integral sign. 1 over 2 power 4 will be 1 over 16. Here we have t power minus 4 dt. So this is here I miss the integral sign. So write it once you write your notes. So now here we have the integral of 1 over 16, 1 over t. So 1 over 16 is just a constant. Integral of 1 over t will be ln absolute value of t minus 8 over 16. Integral of t power minus 3 will be t power minus 2 over minus 2 plus 1 over 16 is a constant. Integral of t power minus 4 will be t power minus 3 divided by minus 3. Then we add the constant c. Now here just we simplify. It will be ln absolute value of t over 16 plus 8 over 16 multiplied by 2. So here we have minus with minus, it will give us plus 8 over 16, 2. So 2 multiplied by 2 will be 4. Then minus, here we have 16 multiplied by minus 3 will be minus 48. Here we have t power minus 3. So it is divided by t power 3. Then we add the constant c.